Okay. So now we're going to be dealing with motion in 2 dimensions. If you were walking, or you're on a bus, let's pretend you're sitting on a bus, and you got a tennis ball in your hand, you're tossing up in the air and catching it every single time. So to you, it looks like that tennis ball goes which way? Up and down, because you're moving. Well, wait a minute, aren't you moving? You're sitting in the bus. The bus is going, let's say, 50 miles per hour. You are moving at 50 miles per hour. Why is the ball landing in your hand, that tennis ball? Because that tennis ball actually is not going up and down, it's moving like this. To land back in your hand, that tennis ball has to be moving at the same speed you are moving. So somebody sitting outside the bus and watching you, they see the tennis ball rising like the way you're seeing it right now. But if the person inside the bus, if you're looking at that tennis ball, to you it looks like this. It goes up, then it comes down, straight up and down. But the reality of that is really that motion. That's what's going to happen to that tennis ball. The only way, because if that tennis ball was not looking like this, if it was going up and down, and the bus is moving at 60 miles per hour, you should not catch that ball. It should land 2 or 3 seats behind you. Because you're in the bus going 65 miles per hour. You just moved. So that tennis ball, this motion here is called projectile. So moving actually in 2 dimensions. You're going up and down, you're moving left to right. The nice thing about projectile is a couple of things you'll find out, that the velocity in the x direction does not change. So the velocity in the x direction is constant. Well, if the velocity is constant, what do we know about the acceleration then? What's the story with the acceleration? Yes, Josh? 0. Acceleration is change in velocity. That's the definition of acceleration. Delta means change over time. If your velocity is not changing, then your acceleration is 0. Well, if your acceleration is 0, when you look at these equations, look at the first equation out of these 5 equations. If the acceleration is 0, that tells me what? Final velocity is the same as what? Initial velocity. Oh, we know that. The velocity is constant. Average velocity, if these are the same number, let's use, for example, 5 and 5. Doesn't matter what number we use. If your velocity is 5, what's 5 plus 5? 10. 10 times a half is 5. Your average velocity is also the same. It's the same number. Constant speed. You set your cruise control at 60 miles per hour. Your average speed is 60 miles per hour. But here's what's going to happen. When your acceleration is 0, if you look at that equation, second equation really, when this is constant, you end up actually, this and this end up being the same equation, which says x equals x sub 0 plus v0 times t. And that's the only equation you will have in the x direction. That's it. When you have projectile, that's the only, out of these 5 equations, they all shrink down to 1 equation. Why? Because the acceleration is 0. If you put acceleration 0 here, this is gone. It says v final squared equals v initial squared. So these 5 equations will narrow down, shrink to 1 equation. And we always make x of 0 where we start measuring, we label that as reference as 0. So if you make that 0, then the equation we have to use, x equals v0 times t in the x direction. There's only 1 equation. In the y direction, your acceleration is not 0. In the y direction, what's your acceleration? The acceleration is what? You're throwing things up or down or horizontal and lands there. What's the acceleration? What's pulling on it? Gravity. Gravity is the only thing, which is what? Negative 9.8 meters per second squared. And all these equations will be available for you to use, all 5 of them. You can use all of them. All 5 equations can be used. It depends what's given to you. So we have to look and see what's given to us and go from there. Decide which one. So let me take an example. I'll start with someone jumps off a diving board, runs, or let's not use a diving board. How about a plane? A plane doing a rescue here. Somebody's stranded there. There's a fire, and we're trying to rescue them. There's some people here. So what will happen, the plane will be flying at a certain height. Let's say the height is 1,000 meters high, the plane. Going at a speed, constant speed of 200 miles per hour. Horizontal, this picture I've drawn horizontally. The plane is not climbing, is not going down. We'll deal with that later. So, and releases a package. The package is going to travel like this. And it's going to land right here. So if there's some people stranded here and you're trying to get some food to them and shelter, let's say Alaska here, some motorcycle guys get stranded there. They can't really get to them for now. They said, let's send them some shelter. Let's send them a tent, some food. They don't freeze. We'll try to get them in the morning. It's getting dark right now. So they're going to drop the stuff. Hopefully it's going to land right next to them, close to them. They don't have to walk that far. And they can grab the tent, set up actually a place to stay tonight, have a fire, get something to eat. In the morning we'll get them out. So the question now, if we release them from this point, this is where we release them. I'm going to ask a few questions. Where is it going to land? What's that distance? Let's start with that one. The other question, let me ask for the time. How long was that package in the air? So I'm looking for the time. How long was it in the air before it hits the ground from the time we released it till it hits the ground? And how far from here did it travel? From this point. So notice we have motion in 2 dimensions. We have projectile. You're moving in the x direction and you're moving in the y direction. The good news actually here, the plane was going horizontally. What does that mean? Your initial velocity when you released that package was in the x direction only. It was in that direction. So let me break it down to x component. And y component. Let's look at the x component. What was the initial velocity in the x direction? What else? What was that initial velocity? When the plane of that door opens and you just let go of that package there, you just open and drops it. What's your initial velocity? Was that package moving when you opened the door? Try again. 200 miles per hour, absolutely. Whatever the speed of the plane. That package is sitting inside the plane and it's moving at the same speed as the plane. So when that door opens, that package actually comes out at 200 miles per hour. So 200 divided by 2.24, we can convert that to meters per second. That's equal to what? 89.3 meters per second. What else we know in the initial? Well, there's only one equation in the x direction. The equation is what? X equals v0 times t. Notice I know v0. I calculated that. The time is unknown, so I really can't do anything about it. And x is unknown. Those are the three things available for me in the x direction. X, v0, and t. If two of them are missing, I couldn't finish the problem here. Let's look in the y direction. What was the initial velocity up and down in the y direction when you opened that door? What was the speed of that object up and down? 0. It wasn't moving up and down. Okay. Once that package leaves the plane, neglect the wind. The air resistance, obviously, is going to be some, but let's neglect that. We have acceleration, which is what? What's the acceleration acting on it? Why is it falling to the ground?
-9.8.
Yep, gravity. Negative 9.8. You want to use the ground as reference for the height? It's up to you. If I use the ground as reference for the height, what was my initial height? How high was it when we opened that door for the plane to drop it? 1,000. And when it hits the ground, what's my final height? 0. So notice that x is not really this x. I should have used y here, you know? Maybe I'll switch to y instead, because you're going up and down. Y sub 0 and y. Because people say, oh, you're looking for x is 0. No. X I'm looking at for the direction, the x direction. Let me use y here. So in the y direction, the initial height I can't really find x when I'm looking in the y direction, but I can find the time. Is there an equation that will find the time using all these? I think equation number 4 on that list is a 4, which says what? Y equals y sub 0 plus v0t plus 1/2 at squared. Instead of x, I use y because you move in the y direction. Y is 0. Y sub 0 is going to be what? 1,000. Now I can tell you, we're looking for the time. Your time better be positive. Time could never be negative. What was your initial velocity? 0 times the time, that's 0. This will be negative 1/2 times negative 9.8, that's 4.9 t squared. (9.8) or negative 9.8 times 0.5 is negative 4.9. So negative 4, well, that becomes a plus if you move it to this side, equals 1,000. T squared equals what? 1,000 divided by 4.9. T squared is 204.08, which means t, you take the square root of that number, 14.3 seconds. So the time is 14.3 seconds. Now, if I know the time, that's one of the questions. Can I find x? You come back to this equation. X equals, you know what v0 is? In the x direction, 89.3. And time is always the same, regardless if you're moving up, down, whatever. Time is 14.3. Roughly is going to be 1,276 meters. So if I'm looking for 3 significant digits here, and that's where that package is going to land from this spot, 1,280 meters away, almost 1,500 yards away. I think a mile is like 1,680 yards, so it's almost a mile away. It's going to land, almost. It's going to be in the air. Eventually, it's going to land there. Let's try another one. I started early by saying a diving board, and I changed my mind, but let's... Somebody jumps off the diving board with horizontal, with initial speed going upward. Five meters per second. It goes up and it comes down. And there's the water. And the question, what is the velocity when they hit the water? What's the velocity or the speed as they hit the water? If we ask for speed, it's going to be positive. If we ask for velocity, it's going to be negative. What's the negative indicate? It's coming down. Now this one went straight up in the air. So it's not really projectile. Projectile when you move in 2 dimension. So this is only 1-dimensional movement. Boom, went up the air and straight down. I couldn't make it straight down because if I made it straight down, you wouldn't see that line. So I just made it look like this, so you get to see what's going to happen. It's going to go up there, come straight down. The only way to be projectile is you got to jump on an angle, which we'll do the next example, where you have something on like this. So what do we have here? We have the initial velocity going upward, which is 5 meters per second. We have the acceleration, which is gravity, negative 9.8 meters. And let's say the diving board was, what's most diving board? 3 meters above the water? Anyone to diving, swimming? Is that a normal size, 3 meters? 10 meters, I don't know what the diving, let's say 3 meters. So if I use the water as reference here, I know my initial height was what, 3? And my final height is 0 when you enter the water. Once you touch the water, that height is 0 because I'm measuring the height from the water. And now I'm looking for the final velocity. So again, this is not a projectile because you went straight up in the air and straight down. Projectile, you're moving up and down and left and right at the same time. So we only have one equation, that's equation 5. We used to use x minus x sub 0 because I'm moving the y direction. I'm changing that to y minus y sub 0. But it's equation number 5. If I'm moving up and down, I'm going to use y's in place of them instead of x's. V squared equals, what's my initial velocity? 5. Square it plus 2 times negative 9.8 y minus y sub 0. So it's 83.8. So what is V? V should be what? The square root of that number, right? And if you put that answer there, you will get it wrong. So you type 9.15 meters per second, they go, not correct. They say find the velocity, and you type in 9.15, it's wrong. Why? Which way are you moving? Up or down? Down will be indicated by what? Negative. So you have to put the negative to indicate you are moving down. They say find the speed, then you don't care. The speed is what? The absolute value of that number. So now let's make a projectile out of this diver. As I said, this is not projectile. To make a projectile, we have to make him jump on an angle so he or she can go in the x direction and in the y direction. So let me change the problem. And again, the diving board, here we go. There's the water. It's 3 meters high. But now instead of going 5 meters per second straight up in the air, the person jumped 5 meters per second initial speed at an angle. What angle you want to use? At 60-degree angle? So now you'll watch that diver is going to look like this. So it's going to go like this, projectile. Jumped in the air. It's going to travel in both directions. So now, once I have motion 2 dimension, it's projectile. I got x direction and y direction. And I'll ask, you know what? I'll ask a few questions. This is the edge of the diving board. I'm going to ask, what's that distance? Find x. And v final. What was the final velocity when the diver hits the ground? Let me make the picture a little bit nicer. This is what we're looking at. Like this. I'm looking for x. X is the distance from here all the way to here. And I'm looking for the velocity here. Notice the velocity here. I don't know if you can see it. It's not straight up and down. It's on an angle. It is on an angle. When we start talking about projectile, the first thing I said today is what? Here's my first one. That in the x direction, the velocity is what? Constant. It remains the same. And there's only one equation. But in the y direction, the velocity changes. So let me find the initial velocity in the x direction. What is my initial velocity in the x direction? What's that velocity? If you've done the last homework, vectors, we know what they answer. Come on, I need to get a coffee. Hurry up. What is it? Well, the 5, Vinny, is not really going in the x direction. And it's not in the y direction. It's in this direction. I need to know what is the velocity in the x. This is the x direction. What's that velocity? That's in the x direction. And this is in the y direction. What's that velocity in the y direction? Isn't that the x component of this vector? And this is what? The y component of that vector. So the velocity in the x direction is going to be 5 cosine 60 degrees. To find the x component, it's 5 cosine, and the y component 5 sine. 5 cosine 60 degrees. It's 2.5. The initial velocity in the y direction is 5 sine of 60 degrees. 5 sine of 60, it's 4.33 or 4.3. So the initial velocity in the x direction is this. The initial velocity in the y direction is that. Again, there's only one equation in the x direction, and that's this one. So I know V0 is 2.5, but I don't know what t is, so I can't find x. I'm out of luck. Let me look at the y direction. I know the initial velocity in the y direction. I just did it right there. I also know the initial height. If I use the water as reference right here, what was the initial height when I jumped from that diving board? How high was the diving board? 3 meters. What's the final height when you enter the water? 0. What's the acceleration? -9.8. Good. Can I find t? Because if I know what t is, I can come back with it here and find x. So let's find t. Now, here's what some people don't like quadratic, but if you use the last or the fourth equation, you will have a quadratic equation. So if that doesn't bother you, that's fine. But if it does bother you, then we'll show you can get around it there. Y is 0. Y sub 0 is 3. V0 is 4.3 times t plus 1/2 the acceleration, which is negative 9.8 times t squared. And I got to move everything to one side because I don't like t squared to be negative. So I'll make it positive. I'm moving everything to the left side, so everything will change sign. Something about negative t squared bothers me. I can solve it, I just don't like it. So I like it to be positive. I can use the quadratic formula. But a lot of people don't like quadratic formulas. I'm not a fan of it. Is there a different way to solve it? If you don't want to do quadratic, you can take two equations by two unknowns and work them that way. It's not really much easier. But you can grab two equations, put them together. Like if you grab the top equation, you don't know what v is. You know v0, you know the acceleration. You'll have an equation that has v and t in it. Then I can use this one. Or maybe I'll use this one first. I'll get the found velocity, then come back and plug it in and get the time. So watch that. So if you don't like to solve two equations by two unknowns, I said don't use this one. Then what do? For those people, so let me write what I know in the right direction. I have a lot of people in the past, they'll do anything in their power not to use the quadratic formula. They just don't like it. They go, I don't want to use quadratic. Give me another option. I say, here's your other option. Take equation number 5 first. If you take equation number 5, and you can find the found velocity, which we know, by the way, we need that. So v initial is 4.3, square it, plus 2 times negative 9.8 times 0 minus 3. Minus and a minus, I'll make it a plus. So when you add them, that's a 77.29. And what is v going to be? The square root of 77.29. And it will be a minus because you're coming down. You went up, now you're coming down. Before you hit the wall, you were moving down. That's what the minus sign for. So your found speed is negative 8.79, we'll go 8.8 meters per second. If you know that found velocity, can you give the time? We have an equation that says v equals what? v0 plus at. V is negative 8.8. Initial velocity is what? 4.3. Acceleration negative 9.8 times the time. How many unknowns do you see there? Only one. When you bring this to this side, it becomes a minus. Negative 13.1 equals negative 9.8 t, and t is going to be what? .34 seconds. So instead of using quadratic equation, if you're not a fan of it, we use two equations to get the time. Now, if I know the time, can I find where you're going to land, x? In the x direction, that was the only equation. We know the initial velocity in the x direction is what? 2.5. We know the time now, which is 1.34. And you're going to land 3.34 meters away, directly below where you jump. 3.34 meters to the right of it. So that's one of the questions. Where are you going to land? I asked for x, and now we figure out x is going to be 3.34 meters. Wow, you landed far away. That's a big jump there. Longer than these two tables put together where you landed. Now the next question, what's your final velocity? I asked for that one. And I can tell you it's not that number. Let's look at the velocity, what's going to happen to it. When you jump, here's my path again. It went like this. So you have initial velocity in the x direction. We calculated that to be what? In the x direction was 2.5. Initially, in the y direction was what? 4.3. What happens as you travel more? The velocity in the x direction does not change. But what's going to happen to the velocity in the y direction? Start to decrease. And when you get to the top here, the peak, there is no velocity in the y direction, just in the x direction. Then the velocity in the x direction here. And the velocity in the y direction start to increase negatively down. Down here. Still 2.5 in the x direction, but this is bigger now. And when you hit the water here, your velocity in the x direction is what? 2.5, and your velocity in the y direction, we calculated that to be what? What was it? Negative 8.8. The negative to indicate it's down. So now you know the x and y component of the final velocity. So v final, this is what we know. Your v final has a value of 2.5 in the x direction, and it has negative, is it 8.5 or 8.8? What did I get there? 8.8, not 5, 8. 8.8 in the y direction. Can you find r and theta? Yep, you have x and y already. So r is going to be what? Or v, if you want to call it, the result. You have the x and y component, Pythagorean's theorem. It's going to be the square root of the x component squared and the y component squared. The x component is what? 2.5 squared. And the y component It's amazing how each chapter leads to the next one. We talked about vectors given x and y, finding r and theta. That's what we're doing here. (2.5 squared plus 9.15). And what's the angle? You're going to be diving like this. What's that angle? Theta. So this is really V, the angle you come into the water with. Now can we find what theta is? is the inverse tangent. Notice you are in the fourth quadrant. If you draw your quadrant right here, through that point, this is the first, second, third, fourth. Inverse tangent of y over x. Second tangent of negative 8.8 divided by 2.5. Negative 74 degrees. Almost straight down, actually. Negative is okay. To use negative value. If they don't want negative, you add to it 360 to make it positive. But you're almost coming straight down. It's not at 90 degrees. If you were at 90 degrees, you'll be straight down, but very close to 90 degrees. So you're coming like this, steep. If they ask you for the speed instead of velocity, just give them that number, and who cares about the direction? Because speed is not a vector, does not have a direction. But if they ask for the velocity, you have to give the value, the magnitude, and the direction of it. I'll do another one. I'll modify it a little bit there. Let's say you're playing golf. I was about to use soccer, but the field is flat in soccer. So golf usually is not even. So let's say you hit the ball here, like this. You hit a golf ball. And you hit it at a speed, we'll take Jordan's speed, he can hit the ball, or Tiger Woods, at a speed, I don't know, of 40 meters per second. If you want to get the farthest distance possible, maximum distance, you want to hit it at a 45-degree angle. So ideally, if you want trying to get that ball the farthest point possible, you want that angle to be 45, but not many people can get 45. So let's say this angle is 40 degrees. So the ball travels like this. And it lands right here. What's the distance? And let's assume this hill now is actually a little bit higher than where we started from. See, if you make a level line like this, I don't know if you can see it, the height of this one is 5 meters. So the ball landed 5 meters above where we hit it from, because you have a little hill there. Again, I gotta find the x and y component for each one. What's the initial velocity in the x direction? Again, initial velocity in the x direction, I'm looking for that speed. And the y direction, I'm looking for that speed. What was the initial velocity in the x direction? That wasn't a good choice to use the same number, 40 and 40. So I'll use 38 degrees here. So you'll know which one's which when I write them down. So the initial velocity in the x direction is going to be what? 40 cosine 38 degrees. Cosine the 38 degrees. 31.5. The initial velocity in the y direction is what? 40 sine 38 degrees. Forty sine 38. Let's do 40 sine 38. 24.6. Again, there's only one equation in the x direction. My V0 is 31.5. I don't know the time yet. If I know what the time is, I can tell you where it's going to land. So I can't do any more in the x direction. I'm done with it for now. What about the y direction? Let's write what do we know. We know the initial height. If I use the bottom here as reference, what was my initial height? Initial height, 0. What's my final height? What's my acceleration? Once the ball leaves that club, what's acting on it? Acceleration. Gravity is the only thing. Gravity is the only thing pulling on it now. Neglect the wind resistance. And I'm looking for t, because if I know t, I can find x, and I'm done with my question. Let's find an equation. I'll do this quadratic just because last time I didn't do the quadratic equation. Instead of using two of them, I'll use the quadratic. I can live with it. I'm okay with math. Y is what? 5. Y sub 0 is 0. V0 24.6 t 1/2 negative 9.8 t squared. I like to move everything to one side and solve it. And how do we solve it? That's a quadratic equation. Maybe I will use the quadratic formula. Remember that? A equals what? 4.9. B equals negative 24.6. And C equals 5. So it's minus B plus or minus the square root of B squared minus 4AC divided by what? 2A. Remember that quadratic equation? Quadratic formula? That will solve for T. We're probably going to have, we should have two answers. Why? We're looking for the time where the ball is 5 meters. Well, it's going to be two answers. Why two answers? One of them is right here, was one on the way up, and one is right here on the way down. So I'm interested in that answer. This is just on the way up, but that's 5 meters right there. So there's two solutions to that problem. You'll see that the shorter time, that's when you're going up The longer time or the bigger time is going to be when it lands, when it hits the ground. Now, some of you might have a button on your calculator that solves quadratic. You can plug in these numbers and you're done. I don't have that. I probably do. I just don't know how to use it. So I'll just use the basic math. Minus a minus, that's a plus. (4.9) negative 24.6 times 5. Two times a, which is 4.9. That number is 605.16. This will be a plus 4.9 times 24.6 times the 5. This is 602.7 over 9.8. Plus 605.16. Take the square root of that. 24.6 plus or minus 7 or 34 I got. Plus 24.6 divided by 9.8. One of them, the plus one, gives me an answer of 6.06 second. The other one's going to be a negative number, which we know doesn't make any sense. Negative 1.04 second. This doesn't make any sense. So the only logical one is this one. That's the time the ball is going to be in the air for about 6 seconds. Well, if the ball in the air for 6 seconds, how far did it go? What's the distance now? X equals 31.5 times 6.06 31.5 times 6.06 can't 31.5 times 6.06 190.89 meters, about 200 yards. So we hit the ball about 200 yards. But if you don't want to use two equations, you have to use the quadratic. Expect to get two answers. One of them will not make sense, or sometimes both of them will make sense. Okay.